From the tallest tree to the smallest bacterium, living things depend on chemical reactions to maintain homeostasis, or a stable internal environment. If left to their own devices, these reactions would take so long to occur that they would be unable to sustain life. Luckily, we have enzymes.
Enzymes are biological catalysts. They are biological because they are found within living organisms, and catalysts because they increase the rate of reaction. That is, they speed up reactions, and they do all of this without being used up themselves. That way, one enzyme can catalyze the same reaction over and over again. Enzymes are able to speed up reactions by lowering something called the activation energy. To understand activation energy, first you have to understand collision theory. Collision theory essentially states that all matter is made up of tiny particles that are constantly moving and colliding with each other. As you can see here with water, when two or more particles collide at just the right orientation and with enough energy, a chemical reaction can occur. The activation energy is the amount of energy a collision must have to result in a chemical reaction. So, what do enzymes have to do with particle collisions? When an enzyme collides with the reactants in a chemical reaction, it binds to them and even changes its own shape to make them fit better. Then, enzymes interact with the reactants to make it easier for the chemical reaction to occur. If the goal of the reaction is to break a molecule apart, the enzyme helps by putting stress on the bonds that need to break. This lowers the activation energy because it takes less energy to break bonds that are already almost broken. On the other hand, some reactions are used to make molecules. Enzymes catalyze these reactions by orienting the reactants in the right direction, and enzymes can also lower the activation energy by creating an environment that makes it easier for the reaction to take place, by making it more basic or acidic, for example. The impact enzymes have on activation energy, and thus on the speed of chemical reactions, is clear to see when you look at this graph. The amount of energy that is necessary for the reaction to take place is on the y-axis, and the progress of the reaction, or time, is on the x-axis. Usually the graph for a chemical reaction looks like this, with the activation energy being this line here from the energy level of your reactants to the transition state, which is the top of this curve. When you have a catalyst, however, you lower this activation energy by creating a different pathway that might look like this. These different pathways are why enzymes can speed up reactions, allowing for them all to occur fast enough to sustain life.
So the next time you're enjoying nature, just remember to say thank you to the enzymes hard at work making all of this possible.